So here we're going to work on problem 37 from chapter 4. And in this particular problem, it says that we have a airplane that was in problem 36, and the plane was traveling at 138.9 meters per second. It was traveling at 500 kilometers per hour, which works out to be 138.9 meters per second, and that the plane fires a projectile at 300 meters per second relative to the plane. That will mean that the initial speed of the projectile, which is going to be in the x direction, is going to be the sum of those two numbers. So it's going to be 300 plus 138.9. So the initial speed of the projectile will be 438.9 meters per second relative to the ground. And I'm going to choose my coordinate system to be where x is to the right and y is down. So that means that the acceleration in the y direction will be plus 9.8 meters per second squared. And I'll say that the initial y height is 0, and the final y height is 800 meters because I called down the positive direction, and so it's going to have fallen down 800 meters. So as we did in problem 36, y will be y0 plus v0 yt plus 1/2 ay t squared will give us the time the projectile's in the air. It ends up having gone down 800 meters starting at its initial height. It's not moving initially in the vertical direction. And I have 1/2 and 9.8 and t squared. So the time that the projectile is in the air is 12.78 seconds. And then if in problem 37 I'm asked how far does it travel in the x direction, then delta x is just going to be v0x times the time. So that's 438.9 meters per second times 12.78 seconds. So it will travel a distance of 5,610 meters, almost 5 kilometers away in those 12 seconds. And then in part B, we ask for the final velocity or the final speed. And so the final velocity is going to have an x component and a y component. And in the x direction, the speed isn't going to change. So in the x direction, the speed is going to continue to be 438.9 meters per second. And then in the y direction, I don't know yet, but I know that in the y direction it starts off not moving, and it's in the air for 12.78 seconds. So the final y speed will be 0 plus 9.8 times 12.78. So that means that the final y speed is going to be 125.4 meters per second. And so as a vector, we're going to the right at 438.9 meters per second, and we're going down at 125.4 meters per second. And so the final speed is the hypotenuse of this triangle, 438.9 squared plus 125.4 squared. And so the final speed works out to be 456 meters per second.